Hey there, and welcome. So, have you ever tried to learn something new? You know, like a musical instrument, a new language, or even just getting good at a video game? You probably remember that initial rush, right? Where you get better, fast. Well, that feeling? It's not random. Turns out there's a hidden mathematical pattern behind how we learn, and today we're going to pull back the curtain on it. So, that brings us to the big question. Is there actually a predictable pattern to how we learn? You might think it's all about raw talent or a sudden flash of inspiration, but, science suggests there's a surprisingly consistent formula that kind of maps out the entire journey from being a total beginner to becoming an expert. Let's dive in.
All right, first up, we're looking at a formula for learning. We're going to unpack the actual equation that scientists think describes how we get better at things.
And here it is. It's called the power law of learning. Now, at its core, it's a really simple, but honestly, a pretty powerful idea. It basically draws a direct mathematical line between how long it takes you to do something, that's your response time, and how many times you've actually practiced it. It's the rule that says practice doesn't just make perfect, it makes you faster, and in a way we can actually predict.
Okay, so here's what that relationship looks like as an equation. Now, I know, letters, symbols, but don't worry about it. The idea behind it is actually super simple, and we're going to break it down piece by piece. No math degree required, I promise.
First up is RT. This just stands for response time. It's literally the time it takes you to complete the task. So think about learning a new chord on a guitar. The very first time you try, it might take you a few clumsy, awkward seconds to get your fingers in the right spot. That little bit of time, that's your response time.
And next up, we've got N. This one's easy. It's the number of repetitions. So back to our guitar example, N is just how many times you've tried to play that chord. Is it your first attempt, your 10th, your 100th? Every single repetition helps us predict how that response time is going to change. Okay, so on to our next section, charting your progress. Now that we've got the theory, let's see what this thing actually looks like out in the real world.
So this simple little equation, it's the mathematical engine behind a concept I bet you've heard of, the learning curve. It's just a visual way to map out and even predict how our skill, or in this case, our speed, gets better with more and more practice.
And this chart shows it all perfectly. Just look at this. On your first attempt, your response time is, let's say, 100. But after just 10 tries, boom, it's slashed down to 40. That is a massive improvement. But then, look at the jump from the 10th to the 100th attempt. It's much smaller, right? And that's the key takeaway here. Your biggest, most dramatic gains happen right at the very beginning. The more you practice, the smaller those improvements get.
And this isn't just a cool observation, it's a major prediction of formal scientific models. For instance, there's something called the EBRW model. That stands for Exemplar-Based Random Walk, which studies how our brains learn to sort things into categories. And guess what? It predicts this exact same curve. So this pattern is really baked into how scientists believe we think.
So it all seems pretty neat and tidy, doesn't it? A simple formula, a clear curve, everything fits. But, and this is a big but, here's where the story takes a really fascinating twist. This law that seems so solid, it's actually at the center of a pretty fierce scientific debate.
Which, of course, forces us to ask a really important question. Is the power law of learning really the whole story? Well, as it turns out, the answer is, well, it's complicated.
And this slide lays out the conflict perfectly. In one corner, you've got the power law, the reigning champ. But in the other corner, you have some serious challengers. Some scientists argue that a totally different formula called the exponential law of practice actually fits the data better. Then you've got another group that argues the whole curve is what they call artifactual, which basically means it's an illusion. They think it's just a statistical quirk you get from averaging lots of people together, not a real picture of how any single one of us learns.
And just to be clear, this isn't some minor academic squabble. As the source material points out, the true nature of this law is, and I quote, frequently debated in mathematical psychology. This is a central mystery that the top experts who study how our minds work are still trying to figure out.
So, with scientists still debating the fundamental formula for learning, where does that leave us? Let's talk about what it all means and why this debate actually matters for all of us.
You know, the fact that this debate even exists is maybe more important than who wins it. It's not really about picking the right formula. What it shows us is this deep, fundamental human quest to understand the precise mechanics of how our own brains work. Learning feels so natural, so intuitive, but mapping it out scientifically, that's one of the great frontiers.
And that leaves us with one final thought to chew on.
If the experts, the people who dedicate their entire lives to this stuff, are still debating the most basic pattern of how we learn, what does that tell us about the limits of ever truly knowing our own minds? Something to think about. Thanks for tuning in.